Guys, and welcome back to another video on the channel. In today's video we're going to be showing you how to name alkanes using the IPUAC naming system. Okay, so this is strictly for organic chemistry. Now we won't be dealing with any functional groups, we'll just be dealing with just plain old alkanes, nothing like alcohols, carboxylic acid, stuff like that. Okay, just how to name them. Okay. So in the IUPAC system, or just in chemistry in general, the way we draw organic compounds, rather than drawing pretty much the atoms themselves like this, so let's say I drew this with 2 carbons and all the hydrogens, this comes a bit tedious over time to draw if you're drawing really big structures. So the way we actually draw this structure is using this notation here, where you just use lines, okay? So I'll draw it like this. So this would be an example of this exact structure, okay? So the edges of the line represent the carbons, and you just assume all of those are filled with hydrogens, okay? So if I wanted to draw this alkane, so I had, say, 4 carbons, and rather than drawing all the hydrogens like this, so I'll just draw it really quick, you can just draw a little stick line pretty much, okay? So you can draw it like this, so you go 1, 2, 1, 2, 3, and then 4, okay? So each of these represents the carbons there, and you assume they are completely filled with those hydrogens, okay? So these are the exact same ideas, just drawn a little differently, okay? So in this video, I'll be drawing these chains like this here, obviously without the color, so it will just be like this, okay? If I wanted to draw a double bond, which I won't in this video because it's just alkanes, I would draw it like this, okay? But anyway, so what we need to know about naming alkanes is we need to know, alright, what's our base of, like, how do we name the first 10 carbons, okay? So if you have 1 carbon, it has a prefix methyl, okay? Or meth, okay? If you're naming 2 carbons, it's going to have ethyl, or just eth, okay? If it's 3, you're going to have propyl, or prop. If you have 4, it's going to be butyl, or butane. Now, if it's an alkane, meaning it only has single bonds with the carbon, it's going to have A and E at the back, okay? So if I were to go, let's say, 1, 3, this would be prop, because there's 3 carbons, and ane, okay? So that's how I would name that basic compound there, okay? If it's 5 carbons, it's pent, so pent. If it's 6, it's hex. If it's 7, it's hept. If it's 8, it's oc. If it's 9, it's I think it's nonane. Yep. If it's 10, it's decane. So these are all the prefixes here, okay? So it's good to know what each of these mean in terms of like their number before moving forward with anything in organic chemistry, okay? Especially with naming, okay? Like I said, if it only has a single bond, you'll use this bit at the back. So this would be the structure of pretty much all of these guys here. So if I were to do this one, it would just be, well, literally just that, a dot, or just like literally something like that, okay? If it's ethyl, there's 2 carbons, then you assume it's like that. If it's propyl, I'll just draw this one like that because it makes more sense rather than just drawing a dot. If it's propyl, it's 3, so it'd look like this. So 1, 2, 3. If it's butyl, 1, 2, 3, 4. Pentyl, 1, 2, 3, 4, 5. Yep, so 1, 2, 3, 4, 5. Hex, hept, oc, non, and then decane. 1, 2, 3. So here, all of these, because they have single bonds, they would have the ane on the back of all of these guys here. Okay, right. So naming them is pretty easy if there's no substituents attached to them. Okay. However, if you have a substituent attached to it, then it becomes a bit tricky. Okay. So, for example, the main idea is if you have an organic compound, you want to name the longest chain. Okay, so if I were to draw this, I need to pretty much count how many carbons I have there. So I would go, all right, 1, 2, 3, 4, 5, 6. So this is going to be, because there's only single bonds and there's no other groups attached, this would just be hexane. Okay, and that's it. However, if I attached, let's say, a group to it, so if I attach something here, we've still got to count the longest carbon chain. Okay, now it's still going to be 6. Because we didn't add on the end, because you could count it like this. You could count it like 1, 2, 3, 4, 5, 6. Or you could count it as 1, 2, 3, 4, 5, 6. Same idea, these would just be these bits here. Okay? Now, with organic chemistry, it's good to understand that you could always rotate your molecule's point of view. So if I were to draw the same one again, 1, 2, 3, 4, 5, 6, you can always rotate the point of view. So this is equivalent to this, okay? It's just been flipped upside down, okay? Because remember, it's a 3D thing we've got to think about. So if they give you a couple diagrams and they say, all right, which of these are different from one another, you've got to think, all right, if I rotate this in any way, can I get that picture up there, okay? This would be definitely different to this, okay? So these would not be the same, okay? Because you cannot rotate this such that you will ever get this compound, okay? Right, now, how to name this guy here. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, yep. So here we're going to name the longest carbon chain. So we agree there's 6 carbons. Now, a substituent is pretty much a group attached to the longest carbon chain, okay? Now we can see here there is a single carbon. So this is a methyl group, okay? Because it's only one carbon, like this, okay? Now you want to name this structure, you want to put the numbers so that the substituent is the lowest number possible. So for example, I wouldn't name the chain like this because the 5 is a much larger number. If I were to name it the other way around, I could give the exact same thing 2. So you see you could get 2 or 5 for the same position here. So you're going to go with the 2 because that's how you name it in this structure, okay? In the system as well, okay? So here, the longest carbon chain is 6. Now we've got to know where that position is, okay? So what we do is, all right, we know it's going to be hexane. So we'll go hexane. Then you've got to go and think, all right, where is the position of that group? So you have to go, all right, that's on carbon 2. So it'll be 2. Then you've got to put a dash, and you've got to put the group that's there. So it'll be methyl. So you can put the methyl here. So this compound would be 2-methylhexane. Okay? So if I were to do this one as well, the one before, we could go 1, 2, so we could name it like this, 1, 2, 3, 4, 5, 6, or we could go 1, 2, 3. So here we're going to name it the opposite way because it gives the substituent the lowest number. So we'd have 1, 2, 3, 4, 5, 6. So this compound would be, because of that position, it would be 3-methylhexane. Okay? So that's the main difference between these guys here. It's the position of that group. Okay? Righto. Now, let's say we had this one here. So let's say we had a couple. So let's say we had, I don't know, 1, 2, 3, 4, 5, 6, 7. We'll go 8. And we'll put 1 here. And let's go 1 here. Okay? How we would name this compound is the exact same idea. Now we've got 2 of the same group. We've got 2 methyl groups attached. Now you still want to name it in terms of the lowest carbon. So we're obviously going to name it left to right. Okay? So it'd be 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is 8 carbons. So you're going to have octane as your main chain. Okay? Now you've got 2 methyl groups. Now their positions are very important. So you have to go, alright, carbon 2 and carbon 3. So you have to go 2 and go dash 3. Now because there's 2 methyl groups, you can use a prefix. So if there's 2 things, you can go di. If there's 3, you can go tri, etc. So because there's 2, we can go dimethyl octane. So what this tells me from this name is that the longest carbon chain of this molecule is 8 carbons, and we have 2 methyl groups on carbons 2 and 3. Okay. Now let's take a look at this one. So let's say we had the same chain or a similar chain. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we had this. So here we've now got 3 methyl groups, but one of them has the same position. So the way you have to name it is the same again. You have to name the longest carbon chain. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice I always do it so these are the lower numbers. Okay, that's very important. Because remember, you can always rotate your point of view. Now we've got a methyl group here, a methyl group here, and a methyl group here. So we have 3 methyl groups. So we're going to use the prefix tri-methyl. Okay. So here what we have to go is we have to actually name the positions. Now we have to put 2 twice. So we'll have to go 2, 2, 3, and you have to go dash tri methyl. And because the longest chain is 9, it's going to be nonane. Non-ane. Okay? And that's how you name this compound here. Okay? Righto, let's take a look at another example. So, let's say we had this one here. Okay? Now this one, oh no, this one's fine. Let's go 1. I'm just going to make sure I draw them right. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And then we need 1 here. And then 1 here. Okay. So, the difference about this compound compared to the others is we have 2 groups, but they're different. Okay. So now we have to think, alright, how do we place one as a priority over the other? Because there's 2 ways you can name it. Now, obviously, you can name it so these guys get the lower numbers. Now, if you named it from this end, if you went 1, 2, 3, 4, 5, 6, 7, 8, you could have 5, 6. But if you name it from this end, 1, 2, 3, 4, you could have 3 and 4. And you're obviously going to go 3 and 4 because that's the smaller numbers. So you're going to choose to name the carbon chain from this end. Okay. So 4, 5, 6, 7, 8. So the longest chain is 8 carbons. So it's going to be octane as your main base. Okay. Now we have 2 groups. We have a methyl group here. And we have an ethyl group because there's 2 carbons here. Okay. Now how do we prioritize what get names first? Okay. Do you name it 3-methyl 4 ethyl octane? Or do you name it 4 ethyl 3-methyl octane? Okay. And the reason why this is a bit tricky is because 1, we have ascending numbers here, but we also have alphabetical order here. Okay. So the way to name it when you have something like this is you always go off alphabetical order. So the E comes before the M. So this compound here is the correct name for this guy here. So this one here would be incorrect. This is the correct way to name this compound here. Okay. So you always go off alphabetical order when it's coming to the substituents. Okay. Alright. Now let's say we had this one. So let's go 1, 2, 3, 4, 5. Oh, I buggered that up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that rubbed. Oh no, that rubbed out again. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's go 1, 2, 3, 4. Let's go 1, 2, 3. And then go 1, 2. Okay, so this one here, we've pretty much got it positioned, so we're going to get pretty much very similar numbers, but we've also got different groups as well. So in this one here, let's take a look at it. So if we name the longest carbon chain, so it's probably going to be this guy here. Now you can also name it probably from this one as well. So if I were to name it this one as well, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could also go 1, 2, 3. Actually, I'll use different colors for this one here. 1, 2, 3, 4, 5, 6, 7, and you can see you get the same numbers. So it's still the longest chain is going to be 10 carbons, independent of which way you do it. Okay. So here we're obviously going to name it from this direction because you can get the two lowest numbers with these groups here. So here you've got 1, 2, 3. So you have a propyl group. So propyl, because there's 3 carbons. And here you have an ethyl, because there's 2. So here, the way you would name this one is you would go, all right, 4 propyl, and then 5, oh wait, no, oh sorry, that's, did I name that right? Which one is it? 1, 2, and there's 2, yeah, okay, yeah, that'd be fine. Cool, because you could name it, yeah, so this one here, sorry, I just had a mind blank. So this one here would be 4 ethyl, 5 propyl, and the longest chain would be 10, so it would be decane. Okay, and that's how you name this guy here. Right. If you have any questions about what we looked at in this video here, leave something in the comments. Now, I'm going to be doing a video strictly with questions very soon. So keep an eye out for that one. But if you are interested in more organic chemistry, leave a like and subscribe, and I'll see you in the next video. Okay.